All right, hello everyone. I have a video here for standard 4 in statistics, so we'll go ahead and get started. Standard 4 talks about describing the shape of data and appropriate summary statistics. How can I summarize quantitative data? So I can summarize a quantitative data set with a value called the median. A median is a value separating the higher half of the data from the lower half of the data in a given sample. Obviously, because we're separating it into two halves, that means that 50% of the data is either above or below the median. So to find the median, there's a couple of different cases that we have to talk about. If I have a sample size that is odd, if there's an odd number of data points, there will be a value that is in the middle, where I would have an even number of data points, an equal number of data points, both above and below. If I have an even number of data values in a sample, there will be no true middle data value. So the median is therefore the average of the two values in the middle. So if there is no true middle, make your own by taking the average of the two values that are in the middle for a given data set. I can describe the spread of a distribution by using what's called the range. The range is just the overall length of the data set, or in other words, the difference between the highest and lowest values in a given distribution. The range is the top minus the bottom, max minus min. How far is it from the smallest up to the highest? Another type of range is called the interquartile range, or IQR. Or formula Q3 minus Q1. Well, what are Q3 and Q1? Q3 is the upper quartile. Q1 would be the lower quartile. Q1 is found by doing the median of the first half of the data. What's the middle value of the lower half of the data? Q3 would be the median of the top half of the data. Now, when I'm finding Q3 and Q1, I would use that same median process, finding the median process I outlined on this slide, but I only do it for the first and second half of the data, not the entire set of data. That would be just finding the median again. Now, when I'm finding Q3 and Q1, I never include the median in the first or second halves of the data when I'm trying to find the first and third quartile. The median splits the data into two halves. It's not a part of either half. These are called quartiles because they split the data set into different quarters. 25% of the data would be smaller than Q1, meaning that 75% of the data would be greater than Q1. For Q3, the upper quartile, 25% of the data would be greater than Q3, and 75% of the data would be less than Q3. Now, when I find the IQR, the interquartile range, I'm talking about what's the total difference or spread of the middle 50% of the distribution. Between Q3 and Q1 would lie the middle 50% of the data. We can use the 5-number summary to draw what's called a box plot. The 5-number summary is made up of the minimum, the lowest value, the maximum, the highest value, Q1, Q3, and the median. We'll make a box plot and find these 5-number summaries here in just a minute. A good way to talk about the spread or distribution of a data set would be in making a box plot. It's just another way to summarize the overall data. We can also use what are called fences to determine if there are any outliers or atypical data points in a data set. To find a fence and use it to determine if there are outliers, we can follow this process outlined here. An outlier is any data point that is more than 1.5 times the IQR amount outside either the first or third quartile. So the bottom fence would be found by taking Q1 and subtracting 1.5 times the total IQR value, the IQR spread. Vice versa, the top fence is found by taking Q3 plus 1.5 times the IQR. Any data point that would be outside that range, from the bottom fence up to the top fence, would be considered an outlier or atypical data value given the rest of the distribution. So I can see that these data points are greater than the top fence, that top cutoff point right there. And vice versa, these smaller data points would be outside the lower fence. They'd be smaller than that lower cutoff value and considered outliers for our distribution. When we make a box plot here in a minute, I mark those data points that are considered outliers with little stars or X's, denoting that they are atypical values given the distribution. All right, so how do we use the 5-number summary and outliers to make a box plot? So obviously the first step, we have to know what points denote the box plot. So we'll need to find the 5-number summary. And we'll mark the location of the min, max, Q1, Q3, and median on a number line. Step 2 is to make the box. So we're going to box in, draw a rectangle around the markings for Q1 and Q3, the lower and upper quartiles. That box would look something like this, as you can see down below. Now that I have those the box made, let's use the IQR to determine if there's any outliers in our data set. So we'll find the lower and upper fence. The upper fence would be Q3 plus 1.5 times the IQR. The lower fence would be Q1 minus 1.5 times the IQR. If there are no outliers present, as we can read here in part A, draw lines from the edges of the box to the min and maximum values. So draw a line from the box out to the right maximum value and draw a line from the box out to the left minimum value. If you found the fences and there are outliers outside those cutoff values, we'll denote those outliers with stars, as you can see right here. There are some outliers in this data set. There are some there are some ages greater than the top fence for the ages of Best Actress Award winners. These would be atypical ages compared to the more younger people when they've won the Best Actress Award in the Oscars. We can use a box plot to determine the type of distribution, the skew of the distribution in a given data set. Notice that the box is off center given the rest of the data. It's closer to the minimum than it is the maximum. So that means that 50% of the data fits within this window from the minimum to that middle line representing the median. So I'm shoving 50% of the data in a smaller window than I would in the larger window here to the right. So there is a tighter range where I'm fitting more data. So I have that mound of data to the left and more spread to those outliers on the right. I also notice that the median is closer to Q1 than it is to Q3. There's fitting 25% of the data here in a smaller mound, then more spread out the other 25% of the data between the median and Q3. Once again, making more of a mound effect. I've got a cluster of data to the left and tail to the right. So this would be a right skewed or positively skewed distribution. All right, so let's actually go ahead and find the 5-number summary and make a box plot. So we have 100, 114, and 125. I'll just write those over here. $100, 114, 125. $135, 150, 172. All right, so I know the minimum be 100. I know the maximum is 172. All right, so the median would be the middle value that separates the upper half and lower half, where 50% of the data is above and 50% of the data is below. Notice that there are 6 data points, so I can't really find a data value in the middle because there is no true middle. So in that case, pick the 2 middle values and find their average. The average of 125 and 135 would be 130. Q1 and Q3. All right, so Q1 would be the 114 we see here in the middle of the lower half of the data. Q3 would be the 150 we see in the median, the middle of the upper half of the data. The IQR that we'll need to determine the fences would be 150 minus 114, or 36. There's a difference of 36 in the middle 50% of their data, because once again, the difference between Q3 and Q1, that's the middle 50% of the data. All right, so let's go ahead and build the lower fence. I'll give that up LF, and the upper fence UF. The lower fence would be Q1 114 minus 1.5 times the IQR of 36. So 114 minus 1.5 times 36 is 60. Now the minimum would be 100. So there's no data value that would be less than or more extreme than 60, smaller than 60. So we have no outliers on the right. Let's do the same for the upper fence. That would be 150 Q3 plus 1.5 times 36, or 204. Notice that the maximum would still be less than that. So there are no data values greater than the upper fence. There are no data values that are more extreme than 204. So we have no outliers on the right. Let's actually do this. So I'm going to make a number line, and I'm going to denote each of these 5-number summaries. So let's start with 100. And we'll go up to about 175. So let's see here, that's a total difference of 75. So let's maybe cut that into thirds. 125 and 150. Now we're going to mark this 5-number summary. we have the minimum at 100, the maximum at 172. The median is at 130. Q1 is at 114. And Q3 is at 150. Make a box around the IQR and draw a connected segment out to the min and maximum from that box. And there would be your box plot. We have no outliers, so there's no need to denote those. You can make a box plot on Desmos. Let me show you how to do that. 100, 114, 125. Let's make a new Desmos graph. We also had 135, 150, 172. All right, so we have 6 total values in our data set. To get the 5-number summary pretty quick, I could just type stats, and then in parentheses, my data set is named A, and there are the 5 different points that make up the 5-number summary. The difference between each of the points in the 5-number summary would be 25%. There's 25% of the data between the minimum and Q1. There's 25% of the data between Q1 and the median, and so on. In another row here, I'll type box plot A. And there's an example of the box plot for the distribution. There is a little bit of skew in this distribution. I can see that the median is closer to Q1 than Q3. The IQR, the box in the box plot, is a little bit left of center within the range of the distribution. So this looks like it might be just a little bit right or positively skewed, but just slightly. It is pretty symmetric. All right, we had another one here of 359, 831, 904. $309, 851, 904. Oops, 359, 831, and 904. Sorry about that. Let's see what else we got here. 615, 211, and 279. 615, 211, 279. $615 and 211. Let's just do this 2 at a time. And then 279 and 505. 279 and 505. All right, so this obviously isn't going to be in order, so let's put it in order just to help ourselves out a little bit. We'll do 211, 279, 309. 505. 615. 831 and 904. All right, so the min be 211. X be 904. Just finding the 5-number summary. The median, since we have an odd number of data points, we will have a true middle. The median would be 505 because there are 3 data points to the left and 3 data points to the right. Separating the middle 50%. So separating the top and bottom 50% of the distribution. Now I'm not going to include the median when I find the IQR, Q1 and Q3, because it's the middle. It's not a part of either the top or bottom half. So Q1 would be 279, and Q3, the upper quartile, would be 831. Which means that the IQR is the difference in those two numbers. So 831 minus 279 is 552. Let's find the fences. So the upper fence, the lower fence. So the upper fence would be Q3 plus 1.5 times the IQR. So 831 plus 1.5 times 552 is 1,659. Our maximum is smaller than that, so we have no outliers. We have no data points that are more extreme than our cutoff fence of 1,659. The lower fence would be the Q1 minus 1.5 times the IQR, so 279 minus 1.5 times 552. So negative 549. There are no data points that are there are no data points that are less than that, so we have no outliers there as well. All right, so let's go from maybe 200 up to 1,000 when I make my box plot. So let's go 400, 600, 800. All right, and then we'll mark this off. So our minimum would be 211. Our maximum would be 904. Median is 505. Q1 is 279. And Q3 is 831. Box in the IQR and connect it out to the right to the maximum and to the left to the minimum. And there's your box plot. I think we'll kind of cut this off here before we look at variance, standard deviation, and the mean. So I'll make another video for that here in just a second. Have a good one.